Here's something strange. Those brilliant yellows and oranges that light up a forest in autumn, they were hiding inside the leaves the entire summer. You just couldn't see them. The leaf wasn't painting itself a new color in fall. It was finally taking off a mask it had worn since spring. Welcome to the Curious Owl, where we find the wonder in everyday things. Today, why do leaves change color? The answer is a beautiful little story about sunlight, sugar, and a tree quietly preparing for winter. Let's take a closer look at what's really happening inside a single leaf. All summer, leaves are tiny green factories. They're packed with a pigment called chlorophyll, which captures sunlight and uses its energy to turn water and air into sugar. That's photosynthesis, the process that feeds the tree. And chlorophyll has one very famous side effect. It makes leaves green. Why green exactly? Sunlight is a mix of every color. Chlorophyll is great at absorbing red and blue light to power its work, but green light, it mostly reflects away. That reflected green is the light that reaches your eyes. So the color we see isn't the light a leaf uses. It's the light a leaf throws back. But here's the twist. Chlorophyll was never alone in there. Right alongside it sit other pigments called carotenoids, the same family that makes carrots orange and corn yellow. They've been quietly helping all summer, soaking up extra light. We just never notice them because the loud, brilliant green of chlorophyll completely drowns them out. So what changes in autumn? Not the temperature first, actually, the light. As summer fades, the days grow shorter and the nights grow longer. Trees can sense this with remarkable precision. That lengthening darkness is the signal, the tree's calendar, telling it that winter is coming and it's time to get ready. Why prepare at all? Because broad, thin leaves are a liability in winter. They'd freeze and they lose precious water the tree can't replace from frozen ground. So instead of feeding leaves it can't keep, the tree makes a smart decision: cut them loose. But first, it wants to take back everything valuable inside. Chlorophyll is expensive to build, it's full of nitrogen, a nutrient the tree doesn't want to waste. So the tree begins dismantling it, breaking the green pigment down and pulling those nutrients back into its branches and trunk for safekeeping. Production stops, and the existing chlorophyll quietly disappears. And this is the magic moment. As the green fades away, the mask comes off. Those carotenoids that were there the whole time are suddenly revealed, and the leaf glows yellow and orange. Nothing new was added. The tree simply stopped hiding a color it had carried all summer long. But that only explains the yellows and oranges. What about those deep, fiery reds and purples, the ones that make a maple look like it's on fire? Those are a completely different story. And here's the surprise: that red was not hiding in the leaf at all. The tree actually builds it brand new, right as the leaf is dying. The red comes from pigments called anthocyanins, the same ones that color red apples, blackberries, and purple grapes. As autumn arrives, some trees pour energy into manufacturing fresh anthocyanins inside their fading leaves, which raises an obvious question: why spend energy decorating a leaf you're about to throw away? And honestly, scientists still aren't completely sure. It's one of the genuine little mysteries of the forest. But there are some leading ideas, and the most popular one is surprisingly elegant. The red may act like a pair of sunglasses for the leaf, a kind of natural sunscreen. Here's the thinking. While the tree is busy reclaiming nutrients from a dying leaf, bright autumn sun can damage the delicate machinery still working inside. A blanket of red anthocyanins may shield it from that harsh light, buying the leaf just enough time to finish recycling everything useful before it finally lets go. Other scientists suspect the red is a warning sign, a signal to insects like aphids that this tree is well defended, telling them to lay their eggs elsewhere. The truth may even be a mix of reasons. What's clear is that, unlike the yellows, red is something the tree chooses to make on purpose at the very end. This is also why the weather matters so much for fall colors. The brightest displays come from sunny autumn days paired with cool but not freezing nights. That bright sun fuels anthocyanin production, while the chilly nights trap sugars in the leaf to feed it. Get that perfect combination, and a forest absolutely ignites. Meanwhile, at the base of each leaf, the tree builds a tiny wall of cells called the abscission layer. It slowly seals the leaf off from the branch, like gently closing a valve. Once that wall is complete, the leaf is barely hanging on, and the next breeze or frost sends it drifting down. It's also why one tree can wear so many colors at once. Different leaves break their chlorophyll down at different speeds and make different amounts of red. So a single maple can blaze with green, gold, orange, and crimson all on the same afternoon, a whole season of change captured in one tree. So the next time autumn lights up the trees, remember what you're really seeing. Not a leaf turning a new color, but a leaf revealing the colors it carried all along, while a tree quietly, cleverly tucks itself in for winter. The whole forest getting ready to rest. That's bite-sized wonder. I'll see you tomorrow.